Hello, can you hear me? Let's see. Let me see if my stream is finally working. Is it working? Hello, hello. Hello, can you hear me? Okay, yes, it's working. Let's see. If it goes down again, I guess I'll stop. Let me see if my stream is finally working. Let's get this going. Okay. I'm just doing a bunch of calculus review for this exam I'm going to take. It's a school exam. Let's see. Get my doc. Pretty new to this. Stats. Let's see, how can I check how many people are here? Okay. Whatever. So, let's do this. Okay. So we're done. Let f and g be functions defined by sin x and cosine x, for which of the following values of a is the tangent line to f at x equals a parallel to the tangent line to g at x equals a? I feel like that question is so much to it, but it's gotta be way simpler than I think it is. For which of the following values of a is the tangent line to f at x equals a parallel to the tangent line? Because if you go 3 pi 4, 3 pi 4, see, I think they're all parallel though. If you go pi over 4, they're always going to be parallel. What's different about 3 pi over 4? I think that's what's different. They're parallel on that right there, because if you take 0, they're parallel, but they're not parallel over the x-axis like that. That perfect positive and negative over 4. Let's see if this is... Yeah, because these are the same value. So I think that's what it means. And then if you just do pi, see what pi is. Yeah, no. So I think parallel in this case, parallel means whichever values, so equal to each other with different signs. This is something I gotta know with the unit circle, so let's test out the values. So sine 0 is equal to 0 and cosine 0 is equal to 1. So that doesn't work. Let's try let's try sine pi over 4, which is 45 degrees, and then cosine pi over 4. So sine pi over 4, 45 degrees, use my reference triangle. We're going to draw it. 45 degrees, pi over 4, square root of 2 for the hypotenuse, and then 1, 1. So sine, so opposite over hypotenuse, be 1 over square root of 2, and then the cosine of that would be SOHCAH adjacent, so 1 over hypotenuse, square root of 2. So they're actually equal to each other with pi over 4. They have the exact same value, and it shows right here. And I'm trying to get just a better understanding of like what is actually going on with this. So that doesn't work because they have the same signs. And then let's try the next one, sine pi over 2, and then cosine pi over 2. So sine pi over 2, what is pi over 2? Well, it's 90 degrees. So if you took that at 90 degrees, is 0, 1. So sine is 1, cosine is 0. They're not equal to each other, so that doesn't work. Now let's try sine 3 pi over 4. So it's looking with a study guide that it's going to be very, like the standard radians that you got to know on your unit circle. So sine 3 pi over 4, and then cosine 3 pi over 4. So sine 3 pi over 4, 3 pi over 4 is actually the, what is that? I should know that. 3 pi over 4, we just calculate it, times 180 over pi is equal to what? 4 pi, so what is that? 240, so it's like 540. 540 pi, so 540 divided by 4, what's that? 1, 4, 1, 14, no, not 7, 4 times, yeah, no, it is 14 divided by 4, I did something wrong. I don't think that's 540. 80 divided by 3 times 3, 0, 24, 3, 540. So it is 540 divided by 4, 1, 4, 14, 3, 12, 2. So that is 135. So it's the same thing as 135 degrees. 135 degrees is how far from 180? It's what? 45? So you use your 45 triangle again. You just use it again. 45, 45. So this will end up being sine 3 pi over 4 will end up being, so opposite of our hypotenuse will be 1 over square root of 2. So opposite over hypotenuse, yes. And then cos SOHCAH adjacent over hypotenuse. But since you got to take into negatives into account, so since it's the sign, it's still positive, but for cos, it would be SOHCAH adjacent over hypotenuse, let it be negative. So these are parallel to the tangent line. So your answer is D, 3 pi over 4. Because yeah, they're 1 pi at 135. 3 pi over 4. Wait, okay, so I got that wrong. No, I didn't, because these are normalized, I think. Yeah, it's fine. It's the same thing as square root of 2 over 2 and negative square root of 2 over 2. Because you just multiply by 2 over 2. So yeah, that works just fine. Or no, I think you'd multiply by just square root of 2 over 2. Yeah. So 11 I feel pretty good about. Okay. Continue. So I got a ton wrong. It's basically a practice test. I got a 31. I'm definitely not prepared yet. Just gotta keep going. So 12 I also got wrong. So let's see. Okay. The function f is given by that. What is the average value of f over the closed interval 1 to 3? So what does average value of f mean? I think it means slope. Slope is an average, right? What is the average value of calculus? I think that's a slope. Is slope the average value of f? No, slope is not the same thing as the average value. Slope of a function ddx, the slope of a straight line. There you go. By taking the integral of a function over the interval and dividing it by the length. So mean value. Let me look at my book. I think it's mean value theorem. Let's look at this. I have a ton of stuff to look over, but I have 2 days. I could do it. Mean value theorem. I think that's a definite thing. Okay, page 144. I think I have this textbook. Yeah, 144. So basically, if you're wondering what I'm trying to do, I'm trying to pass out of calculus 1 and 2. I taught myself calculus over the summer, so I want to get ahead. I don't want to take the actual class, so I thought I would save money and get ahead by taking this exam. If I pass this exam, I get credit for the first class, calculus 1. I don't know if I get it for 2. It's a possibility, but they gotta tell me. So I'm basically bulldozing it. We'll see. Okay, so Rolle's, it's the same as, okay, Rolle's theorem and the mean value theorem. So finding the critical numbers of a function can be sometimes extremely difficult. As a matter of fact, there's no guarantee that critical numbers even exist. The next theorem, credited by the French mathematician Michael Rolle, provides efficient conditions for the existence of a critical number. The theorem stated for a function f that is continuous in a closed interval is differentiable on the open interval such that f. Here, let me check this out real quick. So, let me just label this mean value. I wish I had a camera so I could show you like my writing, even though it's not pretty. It's something. Let me look at this. And
x equals 3x cubed minus 5x on the closed interval from -2 to 2. We first want to find the average or mean slope on this interval. Then, by the mean value theorem, there exists a value c in the open interval from -2 to 2, such that f prime of c is equal to the mean or average slope. Remember, f prime of c would be the slope of the tangent line at x equals c. So once we find this mean or average slope on this closed interval, we'll find the locations where the slope of the tangent lines would be the same as its average slope. Before we do this, let's look at it graphically. The blue graph is the graph of the given function on the closed interval from -2 to 2. The slope of this red line...
Okay, so if you have a closed interval, so if that exists, so f of b minus f of a equals the first derivative of c times b minus a. So that tells you something. Then it gives you a proof. By the way, I watched Professor Leonard's videos. That's how I taught myself. Not really taught myself, but basically, sorta, kinda, probably not.
Passing through the point when x equals -2 and the point when x equals 2 would be the mean or average slope. And then our goal is to find the x values on the function where the slope of the tangent line would be the same as the average slope of this red line.
So what is it asking for? Is given by what is the average value of f over the closed interval. So if a closed interval exists and is differentiable, happening music. Bruh. Should start pretty soon. Okay, so and an open interval exists and is differentiable on A and B. Okay, thank God we're back. Jesus. I don't know why I'm having so many connection issues.
So let's begin by finding the average slope on this closed interval. Remember, the slope is equal